Today we go over offline root certificate authorities and how to build a simple one for use in your Autolab environment. Hi everybody, I'm Brian Romo with PKI Solutions and I'm the shopkeeper here at Minding the Key Store. And we're going to get into building an offline root certificate authority in your Autolab setup. It's the next installment of our lab series. But first, a bit of an Autolab update. A new version of Autolab has been released. It's out on GitHub. Version 4.2.1 has released. I will put a link to the GitHub repository in the description of the show here. So you can click on that if you want to. You can also go through some of the Autolab update steps as we've talked about in our previous episodes. But I just wanted to give you a heads up. So it's some bug fixes. They haven't done any major revision changes. For example, Server 2022 hasn't been added to the library for operating systems that you can deploy. But you certainly want to get the most recent version of Autolab installed. And some of the role bugs, I actually want to get in a little bit deeper and see if maybe the RSAT bug that we saw earlier in the series is fixed. I hope to dig into that this week. What kind of templates or certificates are you focused on in your testing environment? Are you really interested in code signing certs? Are they TLS certificates? Is it for secure LDAP communication? What kind of certificate templates are you investigating, testing, deploying, revision tracking? What kinds of things are you testing in your Autolab deployment? I'd love to hear in the comments below. Please let me know. And before we dive in to the actual build, just a disclaimer, anything that we go through in this lab series is designed for technical evaluation only. Please don't take what we do in this Autolab series and try to put it in a production environment. Please don't use this to deploy certificates to all of your IoT devices for manufacturing or your corporate laptop infrastructure, your mobile device management infrastructure. Disclaimer, disclaimer, disclaimer. This is for technical testing only. Also, some of the decision points that we're making in building out a very, very basic PKI infrastructure is just to kind of give a vanilla deployment of public key infrastructure or Active Directory certificate services. Please don't construe the technical decision points that we're going through here on the channel as what you should do for your production environment for a corporate implementation. Definitely go through the analysis and certificate use case process for your given environment to help inform the kind of architecture that you need, the type of templates that you're going to use, how you store and manage an offline root certificate authority. Please go through that process. And if you're not sure how to do that because you don't have the resources or the experience, engage a professional technical services provider such as PKI Solutions, and they will definitely jumpstart you on that journey to make the right decision points. Because when it comes to PKI, it's not especially forgiving if you oops and build something in a wrong way. Very often, the answer is you've got to burn it down to the ground and start over again, or build a new PKI and migrate to that and burn the old one to the ground. So disclaimer, disclaimer, disclaimer. All right, let's talk the very basics of a root certificate authority, why you have one, why you would want to have one offline, and then we'll go through some of the build steps and we'll do a desktop share and just kind of go through a basic offline root build out. So an offline root certificate authority in its very basic build out is going to be for one purpose, and that's to be the trust anchor, the base of your entire PKI infrastructure, and essentially to authorize or sign certificates for your online or your issuing certificate authorities, which are out in your corporate environment. So typically speaking, your root certificate authority is something that's heavily, heavily guarded. Its private keys are kept very often on a hardware security module, a secure appliance where the private keys are, tracked and encrypted and stored in a very, very secure fashion. The logs are being tracked. Access to the environment where your root certificate authority is, kept with keycard access, and maybe only one or two people can get into that environment, because the idea is that you build your root CA environment and the certificates typically last much, much longer, and your CAs that are underneath those are what actually connect to your corporate environment and issue certificates. So I'm going to do a bit of desktop sharing here. I'm going to jump over and just share. So I'm going to put this in the show notes. This is a securing, planning a certification authority hierarchy, and talking about what kind of security you want with that. And what we're going to focus on for our basic architecture for the Autolab series is what's referred to as a two-tier hierarchy. And what we're going to build today is this offline root CA. Now, it's going to be a virtual machine in Hyper-V that we're going to have access to. Like I was saying just a couple of minutes ago, under ideal conditions, you would have gone through the your policy documentation. You would have physical controls in place for where this offline root lives. In many environments, your offline root is a physical box that's in a rack, that's in a secure enclave with just a handful of people that have access to it. It's very, very stringent for where that lives. Now, I have a test lab that I'm accessing from my studio machine. And so this is a virtual machine on Hyper-V I wouldn't build this for a production environment because that offline root is really just a file that could be dropped on a USB drive and walked out the door. And the keys are not secured by a hardware appliance. They're actually stored in software on the CA itself. And so someone could get access to the private keys for your offline, for your root CA. And then they could start issuing certificates on your behalf. And you really wouldn't know. It could be a while before you know that somebody is actually authorizing other certificate authorities and issuing those CAs. And then certificates off of that in the name of your organization. So we're going to focus on a two-tier hierarchy, and I'll put the link to this in the show notes below. Let's talk server specifications and how we have our offline root built, our Hyper-V root. So I have here a Windows Server 2019, very basic server build. So I've got a C drive and a D drive, single processor, a couple of gig of RAM. This isn't going to be taxed very heavily. Its sole purpose is to be the trust anchor, the root of the PKI chain, and to issue certificates for your online issuing certificate authorities. You're basically authorizing other boxes to be CAs, and this is the source of power that verifies any CAs further down the chain can issue certificates. Okay, so let's go through the root CA install. So we're going to hit Add Roles and Features. Move this up here so we can see the buttons best we can. Okay, next. This is a role or feature-based installation. We're going to target this local machine. I'm logged on with a local administrator account. Again, it's a work group computer. It's not on the domain. I'm going to choose Active Directory Certificate Services. And it asks to install some tools to go with that. I'm going to add those features. I'm going to hit Next. I'm going to leave the feature tree the way it is at stock. Now this part says, hey, if you install ADCS, here's some things that you can do with it. Also, the domain and the name of the domain settings of the computer cannot be changed after the CA services have been installed. So if you have a resource that's on the domain and then you want to make it an offline root and you intend to take it off the domain, you can't do that with CA services installed. So make sure you've got your work group and domain membership decisions ironed out before you start going through this build, or else you're going to have to tear down CA services and then start over. And that's not a whole lot of fun. Okay, so we're going to hit Next. On the role, we're going to choose Certification Authority. This is just going to be a root CA. You can choose to restart the destination server automatically if required. It typically doesn't. And then I'm going to click, it's kind of hard to see, but I'm going to click Install. And it's going to do its install bit. And you can actually close this window if you choose to. I'm just leaving it up so you can see, okay, configuration required, installation succeeded. So we're going to close this, and then you're going to get this notification, this warning icon that's here, which doesn't mean that it's an error. It just means that you need to take some additional steps to configure it. So here's what we're going to do. We're going to configure CA services on this box. So the credentials that we're going to use are the local administrator account for this particular server. I'm going to configure a certification authority. It's going to be a root CA. Now, this is not a member of an Active Directory domain. It's not part of an AD forest, so it can only be a standalone CA. What's the differences between an enterprise and a standalone CA? That's for another video. There's training courses that are available for it. There's Microsoft documentation. But just know that because this is a workgroup computer, intentionally so, I'm clicking on it, I cannot select Enterprise CA. This is only going to be a standalone CA, and that's okay because it's a root. Okay, this is super important. This is the beginning of our PKI infrastructure for our Autolab setup. So we're going to choose root CA. We're going to create a new private key. Again, there's a whole conversation about private keys, especially if you're in a production environment. Your private key should be secured using hardware security modules. All of those extra steps should be taken care of, but we're just going to do software-based here, new private key on the local machine. Again, there's bigger decision points around the cryptography, but I'm going to go a SHA-384, 4096. I'm going to call it ADCS Lab 19 Orca. Validity period, there's a bigger conversation about how long your root certificates last. This is trial software that's going to be around for a maximum of 6 months, so it's really kind of a moot point, but you can leave it at the default if you like. Again, for your production environment, there should be a whole process, a whole evaluation process you go through with how long do your root certificates last for, and then therefore how long your issuing CA certs last, and then how long the certs that you're issuing CAs put out into production last as well. There's a process you should go through from that. So don't take these clicks as technical advice for what you do in production. I'm going to leave it at 5 years. Now for the database, I'm going to go to the D drive. We have 2 different files or folders, and I'm going to create a folder and call it certdb. And I'm going to create a folder and call it certlog. You can name your folders anything you like. We recommend moving these 2 folders off of the operating system drive just so that you're not dealing with drive space issues and CA services going down because your OS drive fills up. So we're going to, so the database location is going to be dcertdb. This is going to be dcertlog, database log, okay. Some people ask when you install certificate services, is there a database license? Do you have to pay for like SQL or something like that? And the short answer is no. There's a special database product that Microsoft has with the role that certificate services installs and utilizes. So you don't have to pay for an extra SQL license or install, SQLite or, any of that kind of stuff, SQL Express. So here we go. And this is really important. Pay attention to these values. You will have to go through a reinstall if you don't get these right. So we're making this a standalone root. We're going to go with SHA-384 4096. This is the basic. We're going to install and manage the keys on this local system. And the database and the log files are going to go to the D drive. We're going to hit configure. It's going to do its thing. Configuration succeeded. So now if we look at, we just search for cert and pull up the certification authority, CA services. And it looks like there is our CA services role. And if we wanted to, we could take a look at event viewer here. And let's go to custom view server role ADCS. Any errors? Doesn't look like there's any errors. CA services has started. So we'll dig into configuration, spinning up issuing certificates, online certificate authorities, processing the RAQ files. How do you handle that? What do you do with trusting this in your production environment? Those will all be done in follow-up tutorials, but I wanted to go through just a basic config of here's how you install CA services, here's some basic settings, and some lab best practices, let's say. So there you have it. There's a very basic root certificate authority build out with a work group Windows Server 2019 build and some basic cryptographic steps and configurations you can do just to get CA services up and running. If you found this content useful or anything on the channel, we would love it if you would do the YouTube things. Like, share, subscribe to the channel, hit the bell notification to let you know new content is coming out. Comment below. Let us know what you're doing with your particular Autolab build out. We'd love to hear and keep in touch. I'm Brian Roma, and we will see you next time.